All right, so we're in section 9.2, and in this section we're talking about arithmetic sequences. So this word arithmetic, we actually say arithmetic if it's an adjective, so arithmetic sequences. And you of course want to recognize when a sequence is, part of the category of arithmetic sequences. And the easiest way to do that is to do something we don't really do. And that is, ask yourself, how would you find the next term? Right. What math would it take for you to find the next term? And if you see the pattern here, we're adding 3 every time. So it's not actually finding the next term that's important, it's what we do. We add 3. And if you add 3 every time, that's called the common difference. The difference between n and its previous term, n minus 1. Right. If every time I take a term and subtract the previous term, or I think the best way to say it is, if every time to find the next term I'm adding 3, then we have something called the common difference, and the sequence is arithmetic. The common difference is 3, the number that I'm adding to get to the next term. So, pretty straightforward question here, 10, 8, 6, and I say continue the pattern, and let's even say I tell you it's geometric, or arithmetic rather. This time I'm subtracting 2 every time, so d is negative 2. The tricky thing is d is invisible. And I use that word a lot, but when something's invisible, it's a little tricky. But if a question just gave you the list and said, this is an arithmetic sequence, find D, you have to recognize what the change is. All right. So we'll look at that very formally. We have these things. We have an arithmetic sequence, and what do we know? The first term. And the first term is sometimes abbreviated without the 1 here as A. And then what else we know is, let's look over here, A sub n equals the previous term plus D. So the way that would look is if I had a sub n minus 1 is the previous term, a sub n. How do I go from here to here? Well, I add d. That's the whole point of what I showed you earlier. And again, we call d the common difference. All right, so a very typical question. Well, I already had this one, but they're going to ask you what the first term is. So they might call it a, or they might call it a sub 1. The first term is, depending on how the question's asked, if they say, what is the first term, it would probably be appropriate to say a sub 1 equals 2. But if they just ask you, what is A and what is D, that's a beautiful way to summarize an arithmetic sequence without listing any numbers. It's essentially just giving you the formula or the recipe to make it. Well, A is the first term, it's 2, and then D is 3 because I add 3 to make all of the next terms. And if you don't have a common difference, in other words, if you're not adding or subtracting the same number each time, it's not an arithmetic sequence. The only things we're talking about here are arithmetic sequences right now. All right, next page I want to show you is this. So it's still true that when we see a sequence, like we did in section 9.1, we want to be able to find the formula a sub n. We want to be able to find the formula based on n. So n's the only variable here. A1 and D are numbers that we just know, once the problem starts, or we need to find. But this is an amazing breakthrough. We actually have a formula to find the formula for A sub n. I call it an amazing breakthrough, but you only know that if you were looking at the 9.1 sections recently. So let me go over the old way, well, the 9.1 way that I might have suggested you, so a student work on this. So we notice that we're adding 3 every time. And there's a much more familiar list where you add 3 every time. When I did this in another section, I was counting by 2s, and I said you did that when you were 5 or 6 years old. Counting by 3s, you're probably older when you first did that, but obviously you can. You can go 3, 6, 9, 12, 15. That is a very familiar sequence, which I would summarize as 3n. 3, 6, 9, 12. It's 3 times 1, 3 times 2, so it's 3n. But look at the sequence I want. It's not the same sequence every time the entries are 2 more. So we know the answer, or one way to write the answer for this is, I should be writing A sub n. A sub n equals 3n plus 2. That is where we left this discussion in 9.1. So this was the previous sections method for doing this. Now what I said a moment ago is we now have a formula to find A sub n where you're just substituting into this formula, so you don't have to reach back into your elementary school, or maybe even kindergarten number facts. You can just use something that the book actually taught you, right? And I know students seem to like that. Students seem to prefer actually having a formula to fall back on rather than being required to recall something that they learned 10, 15, 20, 30 years ago, whatever it is. And I get that, all right? But that's why I say this is a big deal. All right, so what was the first term? By the way, I'm kind of giving it away. I know what answer I'm going to get if I simplify it. I'm going to get A sub n equals 3n plus 2. But the first term, that's visible, it's 5. What's D? Well, I look at this, and it looks like I'm adding 3 every time. Confirm that, yep. So I put a 3 there. So this is 5 plus 3n minus 3. And lo and behold, I get 3n plus 2, which is exactly what I would have gotten without knowing section 9.2 or this formula. But again, it's a tall order to ask everyone in a class to think of 3, 6, 9, 12, 15 equals 3. And when that's not something that I or your previous teacher or your previous teacher or your previous teacher taught you, it's something you learned so long ago, it just might not be something that you're as ready to recall. So the author actually kind of stopped working after the substitution. That feels really weird to me. Certainly could have taken the time to write 3n minus 2 here. But I do want to point out the entirety of this question. So this question was actually asking us to find the 38th term. So if you did simplify, you'd get 3 times 38 minus 2, which I'll take their word for it, is 1/16. So it's not just finding A sub n and finding the formula. Sometimes they're going to ask us to find a term. Now let's back up on this. Some students would try to find the 38th term just by extending the list, but I keep on telling you, that's not what they're trying to get us to do. They're not trying to get us to make a list 38 terms long to find the 38th term. They want us to be more mathematical than that, more clever than that, I suppose. And I will warn you that, if an example like this is in the book or on the website, one time it might say the 28th term, and you say, oh, no problem, I'll do 28. And then the next time it might say 58, just because of the random nature of the website. I keep on saying my personal limit is around 20, which is quite a bit. I would calculate 20 more terms than I was given, but I certainly wouldn't want to go out to the 38th term. So formulas make it happen. So I just want to emphasize, this is a formula you need to know, and you need to know what it does. Right? It finds that a sub n equals whatever from a list, rather than us having to find it using 9.1 methods. All right. I want to get to the next formula. So the next formula in this section is another nice one, but you have to understand what it's doing. So when you have a sequence of numbers, a series rather, you might be asked to add the terms from the first to the nth term. Now we've already done this in the other section as well, but we were using formulas with sigma. I don't know if you recall that, but look at the other video to see that, the 9.1 videos. But when it's an arithmetic sequence, we have these two formulas for that. So this is different. This is a lot different than finding the sum of the first, like 1 squared plus 2 squared plus 3 squared up to, 10 squared. We have special formulas for that, but this is for any geometric sequence. So it could start not at 1, it could start at any number. And as long as it's an arithmetic sequence, we can find the sum just using these two formulas. And it's worthwhile, I wrote S sub n both times because it's worthwhile knowing each of these as independent formulas. And we'll see how it works, but you can find the sum of the first n terms if you know n, if you know the first term, and you know the nth term. By the way, in this case, in both of these cases, n is not some mysterious, n isn't a variable anymore. It is the number of terms. So personally, I don't like this formula to have an n in it. N was great when it was a variable, and we used it that way. This is not a variable, so anymore, it's a known value. So I wish they'd used k. Just a personal preference. But just understand, n switched to meaning a number. I'll give you another example of that. In Algebra 1, very, very early in Algebra 1, x is a variable, but if you want to find the distance between 2 points or something, or slope of a line, let's say that, they give you x1 comma y1. x1's not a variable, it's a number, like 3 comma 5, right? So in other classes, when they say x1, they mean a number. When they say x, they mean a variable. I wish they did this here. If they kept n to be a variable, but here it's not a variable. So we'll see how that works. Let's look at one. Actually, they did keep it a variable here, but so this one, this first one I like, it would be a good example of that, of n being a variable. All right. So what do I mean by that? We have this list. We know what the first term is, what a is. It's 5. We know what d is. It's 2. And we don't know what a sub n is because n is still a variable. I mean, it's not a number in this case. So they're just asking us to find a formula for s sub n, and they're choosing this formula because they know a sub 1, they know d, and we get a formula for it. So if you wanted to find the sum of the first 10 terms of the sequence, you'd plug a 10 in to this equation. And that's a good use of the formula. A more common example would be this one, and this is what I was talking about, where n stops being a variable and starts being a number. All right, so what numbers do we have? This 51 is A1. 84, it's a sub n for now, but I need to know what n is. And then d is 3. I'm adding 3 every time. All right, so this is a problem. I need to know, well, I know what a sub n is, but I need to know n. And if you don't understand why I need all these values, we'll look at our formulas and we'll see. All right, so they use this formula to solve for n. N is the thing that we're looking for, and so we can use this formula to find it. So for the first formula we're given, you can substitute everything else in, and you find that n equals 12. And what that means is there are 12 terms in this sequence. So a sub n can be replaced with a sub 12. Now, do you remember the formula? It's n over 2 a1 plus an, or 12 over 2 a1 plus a12 in this case. And that's the formula that they substituted into. So take the formula, make the substitution, and we just added up 12 numbers. Well, yeah, it is 12 numbers. Just that fast by performing this calculation. I'm trying to think if there's anything else we do. Oh, yeah. There was an example I kind of ran past. Sorry. Going backwards. All right. So this is the most complicated type of problem, kind of the mysterious problem. This feels like one of those, I don't know, puzzles you might see at the end of a game, back of some the newspaper, old newspapers would have right next to the crossword puzzle, some other kind of puzzle. All right, but it's not trivial. It's a good style question. All right, so you're given. Sorry, let's get to the start of this. You're given this mystery. There's a sequence, arithmetic sequence. The 8th term of the sequence is 8, and the 20th term is 44. So 1, 2, 3, 4, 5, 6, 7. 8th term is 8. That's an ugly 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And the 20th term is 44. And they're not asking you to tell us every term. They just want to know what is the first term and what is the common difference. Well, basically, that's what they will ask you for. So find the first term, find the common difference. We'll get to the others as well, but that's the goal. All right, so there's a formula that we all should know. And what happens when n equals 8? Well, we already know that a sub 8 is 8. And then if I put 8 in this formula, Remember, I don't know what this is, but I can put an 8 here, and I do know what D is. Oh, no, sorry, I don't know what D is. So if n equals 8, I can replace the n with 8. And that becomes a 7, n minus 1 is 7. So I get this side of the equation. How about when n equals 20? Remember, it said the 20th term is 44. So if I put 20 in this formula, I get 20 minus 1, that's 19. So I get these formulas pretty quickly just by writing what the equation said. All right, well, it's a system of equations. If I subtract this bottom one from the top one, the a's cancel. I get 7d minus 7d minus 19, negative 12d. I get 8 minus 44. I get negative 36. So I do calculate that d equals 3. So that was a system of equations. I know that d equals 3. So coming back to my list, I know that this term on this side would be 11. This term on this side would be 5. Let's keep on going with this. This term on this term would be 2, negative 1. The reason why I'm subtracting 3 is when I go to the right, I add 3. So when I go to the left, I want to subtract 3. Negative 4, negative 7, negative 11, negative 15. Now that's not a technique for finding A. I was just overwhelmed with curiosity, so I went ahead and found it. Once you have D, you can find any term, and I wouldn't do it for 20 terms, but however many terms I did it for, 1, 2, 3, 4, 5, 6, 7, 8, yeah, I'm okay with trying for 8 terms, just using the pattern. Just want to double check that I did it right, subtracting 3 every time. Okay, we'll see. All right, well, I didn't need to do that. I could have taken this d equals 3 and substituted it into one of our equations, just like you normally do when you have a system of equations. Substitute d equals 3, which we calculated earlier. And I did make a counting error. Man, negative 13. Something fell off. I didn't see it. Subtract 3, subtract 3, subtract 3, subtract 3, subtract 3. Well, I certainly went to 4 here. What happened? Sorry, subtracting 4. Subtract 3, that's 10. Subtract 3, it's 13. All right. That happens when I talk and write at the same time. It is negative 13. So what happened? My formula fixed my list. And by the way, that's why I don't like making very long lists, because at some point, yeah, I get thrown off. All right, I think that's it. That is for arithmetic sequences. But let me summarize. We have a few formulas here. A formula for a sub n, which gives you the nth term, and a formula for s sub n, which gives you the sum of the terms, and that's it. In our next section, we're going to talk about a different formula where there's a third piece to the puzzle, which seems kind of strange, but it's what what I'm calling S sub infinity, and that would be what happens if you had a sequence where the numbers were progressively getting smaller. Could you add the entire sequence, the entire length of the sequence? We don't do that with arithmetic sequences, but we will do it with our next type of sequence. And so I thought I'd leave a little mystery by telling you what's going to happen in 9.3. But this isn't 9.3, this is 9.2. And that's everything we need to know about this section. So I'll see you in the next video.